right, ladies and gents, this is section 2.1. So everybody turn around, face forward. All right, I'm going to do on your notes and under modules, you guys have your notes for 2, 1. It's part 1 and part 2. I'm just going to do it all together. At the beginning here, this is a super big review. So don't get upset at me or offended if I say something and you're thinking, oh my gosh, I already know how to do this. Okay, fine, that's good. In this first question, it says to plot the following points on a coordinate plane. Somebody remind me again, if I have 2, 3, which one's the x, which one's the y? 2 is x, 3 is y, okay? We move which way first? Horizontal. We move horizontal. We move left and right first, then where? Then up and down, vertical, all right? Everybody with me on that? We remember that? So the point 2, 3, I'm going to start right here at the origin. I'm going to go over 2, up 3, and I have a point right here. Everybody agree with me? Yes? Yeah. Okay. So my next point of negative 2, 3. Start at the origin and go where? Down. Negative 2, comma 3. Where do I go? Left 2, up 3. Yes? You guys with me? Okay. What about the point 4, comma 5? Start where? Origin. Start at the origin. If it's 4, 5, where do I go? 4 right. Right 4, then where? Up 5. Up 5, okay. And then I have my point 4, negative 5. Start where? Always. Negative 4. 4. Is it 4 or negative? Negative 4. This one right here. Oh, no. 4, negative 5. Start always where? Origin. At the origin, at 0. If I go 4, negative 5, where do I go? Tell me. Right 4. Right 4? Down 5, okay? Let's just do this last one right here. Negative 4, negative 5. Where do I go? Left 4. Negative 4, negative 5. Left 4, down 5. So here. Okay? So remember, we always start where? Where do we always start? At the origin, at 0, 0. We go left and right first, up and down second. So here, if you're given points and it says write the coordinates, all right, let's look at A. What is the coordinate for A? If I start at 0, how would you tell someone directionally how to get to A? 5, 1. You go right 5, up 1. So it would be 5, 1. Everything in this first quadrant right here is positive, positive. What about B? What's my B? 1, 2. I go right 1, up 2. Good. What about C?
6, negative 1.
For C, I went negative 2. Where? 6. Negative 2, bless you, 6. Guys, remember, it's always left and right, then up and down. So I went left 2, up 6. What about D? Negative 6, what? Okay, so negative 6, 2. Everything in this quadrant, this happens to be quadrant 4, is negative, positive. What about E? How would you get to E? Good, negative 4, negative 1. What about F? Negative 2, 0. Good. Negative 2, 0. What about G? Negative 1, negative 3. Good. This quadrant is the third quadrant. Notice, what are the signs of both X and Y when we're in the third quadrant? Negative, negative. And then what's my H?
2.
Positive 2, then negative 2. Good. This is the second quadrant, and this is positive, negative. It's really important, guys. Signs make a huge difference. They tell you if it's to the left or to the right, to the up or down. Anything that's positive is either going to be right or up. Anything negative is left and down. So think about that. So as we go through this, we're not going to plot many points, that sort of thing. We're just getting ourselves a reminder. We are going to be talking today about distance and midpoint. Okay, there's a couple things you need to remember about distance. Distance If I tell you I live 3 miles from here, or you tell me you're 6 feet tall, or you're 17 years old, distance is always going to be what kind of a number? Positive. We don't measure distances negative, guys. So make sure, first of all, you remember that. Distances are always positive. But the distance between 2 points is what we're going to be talking about. And we're also going to talk about midpoint. What is the midpoint of a segment? Part where what? In the middle. Good. So here is the distance formula. You guys have seen this a million times. A million times. It does not matter. Listen to me. It does not matter which one you make x1, which one you make x2. It doesn't matter. Don't get hung up on, oh no, which x do I have to put first? Don't do that. Worry about keeping x's together and y's together. But the way that we find the distance formula is you subtract the x's and square it. You subtract the y and square it. Add it together, take the square root. We're going to do this a million times so we get this in our head. But the reason it does not matter, if I have -1 minus 4, right? And I square it. Or if I have 4 minus -1, and I square that. Well, guys, what's -1 minus 4? -5. And -5 squared is 25, okay? If I have 4 minus a -1, what does that equal? +5. What's 5 squared? 25. This is why it's not going to matter. As long as you keep your x's together, it does not matter which one you put first, which one you put second. You just really have to pay attention to signs. That's going to get us, so we got to pay attention. So if I look here, I'm given 2 points, and I want to find the distance between them, okay? First of all, plot your points. Where is A? How would I get to point A? How would I get to point A? Right 2 and up 5. So I go 2, 5, and I plot my point. This is A. And then how would I get to B? Right 4 and down 1. So here is B. And I'd connect my line. I want to know how far it is from A to B. Since this is not a vertical or horizontal line, I can't just count. I can't just count the little tick marks or the boxes and say, oh, this is how long it is. So we have to use the distance formula. So let me show you what I think you guys should do every time you do this. You're going to do what you want to know. But the first thing I'm going to do is I'm going to write my points. I have 2, 5, and I have 4, -1. I'm going to write them on top of each other. I know this is my x, this is my y. So that way I can see, okay, I got to keep these together. X's stay with x's, y's stay with y's. You guys with me? All right, now, I know that the distance formula is underneath a big old square root, so I'm going to go ahead and write it. The distance formula, you subtract your x's and square them. You subtract your y's and square them and add those together. I would do this every single time. Write your shell. Write your formula so you know what you're doing. You got minuses in the middle of each parenthesis, and you're adding those two things together. All right? If you guys do this, you will not make as many mistakes. So in our first parenthesis, I need my x's. I don't care if you do 2 minus 4 or 4 minus 2. It doesn't matter. Why doesn't it matter? Because what are we going to do at the end? We're going to square it and it's become positive. So I'm just going to put 2 and 4. And then I do my y's. I have 5 and -1. Doesn't matter what you put where. I'm going to put 5 and then -1. Everybody see that? So now we can simplify a little bit. What is 2 minus 4? -2. Plus, what is 5 minus -1?
6.
6. Good. 5 plus. So I have 6 squared. Anything underneath your square root, guys, you should always come up with a positive number. So if you come here and you say, oh, it's -4. No, it's not. What is 2 squared? 4. So it's 4 plus, what is 6 squared? 36. So I have the square root of 40. That's the distance. I'm going to talk to Mr. Marks and Mr. Rivera about calculators. I don't know if we're going to do decimals or anything like that, so we'll talk about it later. But when I get to this point, I need to say, oh, can I break this down? Can I break down 40? Is there a perfect square and a non-perfect square in 40?
Yeah.
Yep. What times what is 40? 4 times 10. Good. So when I break that down, what is the square root of 4? 2. So 2 comes outside and 10 stays inside. So the distance from one point to the other is 2 radical 10. That's the hardest thing we're going to do today is just the distance formula, and midpoint's even easier. But you guys we got to practice this. You have to do this a bunch of times to make sure you understand the formula and all that good stuff. Okay? All right. So, whoops. Next one. We're going to talk about midpoint. What did we say the midpoint was? The middle. Okay? How do you guys find the middle of something? Okay, how do you find the average of anything? If you were trying to find your average, what do you do to the numbers that you have? You add them and then divide by however many, right? If I have 2 points and I'm trying to find the average pretty much of those, you add the points together and divide by what? 2. That's all we're doing. That's all midpoint is you add the x's together, divide by 2. You add the y's together, divide by 2. Here's the formula. It's nothing real crazy. You just add the x's, divide by 2. Yep, this is our midpoint. So if you are asked here to find the midpoint, let's plot our points. Negative 2, 5. Negative 2, 5 is here. My other point is 4, 9. So 4, 9. It's a good idea to plot your points. So when you get the midpoint, you can kind of look on your graph and say, oh, that makes sense. It's kind of in the middle of that line. If you get an answer and it's not even on that line, then you must have done something wrong. So make sure you pay attention to that. So again, guys, to find the midpoint, this is what I would do. I would write down my points. Negative 2, 5 and 4, 9. Write them on top of each other so I know my x's are first, my y's are second. Now, how do you find the midpoint? What do we say we do? You add the x's and divide by 2. So I'm going to say negative 2 plus 4 divided by 2. Right? That's my x. And then what's my y?
Negative 5.
5 plus 9 divided by
2.
Perfect.
It doesn't matter which order you put it in.
Nope. You could do 9 plus 5 or 5 plus 9. So what is negative 2 plus 4? Negative 2 plus 4 is 2 over 2, right? I know. What's 9 plus 5? 14 over 2. Can we simplify those?
Yeah.
Yeah. What's 2 divided by 2? 1. And what's 14 divided by 2? 7. So I found that my midpoint, the point that's in the middle of this line, is at 1, 7. Let's just look and see if that makes sense. If I were to go over 1 and up 7, does that look like it's the middle of that line?
No.
It doesn't? Yes, it does. This is a way you can check yourself. A lot of us in here like to check. So I would just draw a quick little sketch of your 2 points, join them together, and then check. If, say, I did something and I had a sign error and I had 1 negative 7. If I went to check and I said, oh, okay, went over 1 and down 7, right away you should go, oh, I must have done something wrong because that point is not in the middle of my line. So just check yourself, guys. It takes 2 seconds to do. How many times can I go back? There we go. How do we feel?
Great.
Okay, good. I like it. All right, which of the points is closer to 5, 3? So let's plot A at 5, 3. Over 5, 1, 2, 3, up 3. Here's A. All right, and then we're talking about 2 different points. I'll do one in green, so 1, negative 2. This is P. And then I'll do Q, 8, 9. 8, 9. They want to know which one is closer. What's your guess?
They're equal.
Okay, they look like they could be equal. I agree. But mathematically, how would you prove to me which one is closer? I would do the distance formula. I need to know how far it is from P to A, and then I can compare it with how far it is from what? A to Q. So we're going to do the distance formula how many times? Twice. So let's get that set up. I'm going to do, doesn't matter which one you do first. I'm going to do A to P. So A is 5, 3, right? And P was 1, negative 2. So let's do the distance formula between these two. Let's get our formula set up. I have a big old square root. Then I have 2 parentheses. What's in the middle of each parenthesis? A subtraction sign, good. What's in the middle of the 2 parentheses? What separates them? An addition sign. And what am I missing? My squares on both of these. Right? Now that we have that set up, all we're doing is just plugging in numbers. I need my x's. What are my 2 x's? 5 and 1. Does it matter where I put the 5, where I put the 1? Nope, just put them, make sure they're in the same parentheses. So I'm going to write 5 and 1. Now, what are my y values? 3 and negative 2. So I'm going to put my 3 here, my negative 2 here, and now we just simplify. Guys, what is 5 minus 1? Positive 4. So I have that. Plus, what is 3 minus a negative 2? What's 3 plus 2? 5. Good. So what's 4 squared? 16. What's 5 squared? 25. What is 16 plus 25? 41. Is that going to break down at all? No. Okay. So what we just found was how far it was from A to P. Right? Yes? Okay. So now we're going to do the exact same thing, but between what 2 points? A and Q. So I'm going to come over here. I'm going to write, okay, A is 5, 3. And my Q was 8, 9. Okay, so let's get our shell of our formula. I have my 2 parentheses with a plus sign that separates them. I have squares on both my parentheses, and I have minuses in the middle. So what are my x values, guys? 5 and 8. So 5 and 8. Doesn't matter where I put them. What are my y values? 9 and 3. 3 and 9, same thing. Okay, so let's simplify. What is 5 minus 8? Negative 3. Plus, what's 3 minus 9? Negative 6. What is negative 3 squared? Positive 9. What is negative 6 squared? 36. Okay. What is 9 plus 36? How much is it? 45. Okay, 45. Now, can I break down 45? Yeah. I can. But I'm not going to right this second. Why do you think not? Because then you're going to get some kind of a square root or whatever. But look, all we need to do is compare. Which number is bigger? 45. The square root of 45. Do you guys know what the square root of 45 is? No. But the whole number 45 is bigger than the whole number 41. So that means the square root would be. So the way that you would answer this question, it said which point is closer. So you would tell me what point is closer. P is closer to A. Are they really close in value? Yeah. Square root of 41, square root of 45. That's not far off. But P is a little bit closer to A than Q is. You guys see that? Okay, last example, and then we're done. It says, show that the quadrilateral of vertices, blah, 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 is a parallelogram by proving its 2 diagonals bisect each other. Okay, there's a lot going on in this problem. First of all, they gave me 4 points. I need to plot them. So P is at 1, 2. So 1, 2. Then I have Q is at 4, 4. So 4, 4. And then we're at 5, 9. So 5, 9. And then 2, 7. So 2, 7. And they told me this was a parallelogram. Now, it says to prove that it's a parallelogram because their diagonals bisect each other. What does that mean? What's a diagonal? How would I draw a diagonal? If I started right here, a diagonal would come here, correct? If I come here, my diagonal goes here. So to prove that they bisect each other, it means they do what? They cross where? In the middle. In the middle. So what formula do you think you would use to show that they cut each other in half? They cross in the middle. The midpoint. Good. So let's look at our points. P was 1, 2. Let's label them. 4, 4 is Q. R is 5, 9. 5, 9 is R. Okay, so we have P, Q, R. What am I missing? S. Okay, guys, so think about what the question says. I know you guys are looking at this and you're thinking blah, 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 geometry. We're going to prove algebraically that these bisect each other. Again, bisect means to do what? Cross. How? Where? In the middle. We're using two formulas today. We're using the distance formula and the midpoint formula. So which one is going to show me that one diagonal cuts the other one in half? Bisects it. The midpoint. So which 2 points am I going to use compared to which other 2 points? Where are my diagonals? Tell me my diagonals are what segments? PR and SQ. Perfect. So how many times are we going to do the midpoint formula? Twice. So again, I think you guys should follow the way that I'm doing this just because this will minimize mistakes. I'm going to say S and Q first. So let's be organized. What's my coordinate pair? What are my X and my Y values for S? 2, 7. Good. And then what's my Q again? 4, 4. Good. I tell you guys to write them on top of each other. So you have your X's lined up underneath. You have your Y's lined up underneath. You're not looking back and forth and averting your eyes. Excuse me? Oh, okay. I'm sorry. I thought I did something wrong. Okay, midpoint. How do you find the midpoint again? Remind me.
Midpoint formula.
Okay, the midpoint. Agreed. The midpoint formula. But what is it?
X
Good.
plus X.
Over 2.
Plus. Good. Plus. Plus, plus, plus. So let's set this up. I'm going to add my X's. What are my X's again? 2 and 4. So 2 plus 4 divided by 2, comma. What's my other one? 7 plus 4 and divide by 2. So simplify. What's 2 plus 4? 6. So 6 over 2. What's 7 plus 4? 11. So I have 11 over 2. Good. Can I simplify 6 over 2? Yes. What's 6 divided by 2? 3. Can I simplify 11 over 2? Kind of. Okay, how can you kind of simplify it? It's what? Okay, you turn it into a decimal. We can make it into a mixed number. How many times does 2 go into 11 without going over? 5 whole times, right? And then how much is left over? A half. So we can write 5.5. You can write 5.5. If you want to leave it as 11 over 2, I'm okay with that. The only thing is you have to know where 11 over 2 is on a graph. Is it between 5 and 6? Is it between 10 and 11? Is it between 12 and 14? Where is it? Between 5 and 6. Okay, so we found the midpoint of S and Q to be 3, 5.5. Agreed? Yes? No? Maybe? Hi. Hello. Okay. So now what am I going to do? Because I forget. What was the whole purpose of this problem? If they bisect each other. How do I know? Okay, so I work this out. I work out the other one, and I get another point. How do I know that they bisect each other? Okay, you can plot it. They should be the same. Good. So I'm going to now find the midpoint between what two? P and R. So let's set that up same exact way. Check. Make sure I write everything down right, guys. P is 1, 2. And R is 5, 9. Agreed? Okay. So again, remind me, how do I find the midpoint? Add the X's and divide by 2. How do I find the midpoint for the Y? Add the Y's and divide by 2. So I have 1 plus 5 divided by 2. 2 plus 9 divided by 2. What is 1 plus 5? And 6 divided by 2 is? Good. What is 9 plus 2? 11. What do we say 11 over 2 simplifies to? God bless you if you wanted to. God bless you. 5.5. Okay, so let's compare. What do you guys notice? The midpoints are the same. So you just proved to me that those two diagonals bisect each other. Okay, we talked about distance today and midpoint. What do I know? It's really super important to remember about distance. It's always going to be what kind of a number? Positive. Guys, the best thing you can do is to stay organized. Remember, if you have a negative number, you need to hug it. Put it in parentheses, because if you square a negative number, it becomes what? Positive. We'll make mistakes. On our quiz on Friday, I know some of us are going to make mistakes and say negative 4 squared is negative 16. No, it's not. Agreed? You guys with me?